Yeah. Am I visible to you?
Are you visible or the screen?
No, am I visible to you or not? And
No.
the screen also. Okay. The screen is visible to you?
Yes.
Okay, okay. Let us start the class. By the way, your camera is on, but I can't see you. Let me see what the problem is. Okay, so let us continue. So in the previous class, we were learning about common multiples, right? So we were learning about common multiples of given numbers, and we learned how we can find the common multiples. Okay, now also one more thing, Habib. Do one thing, just like you have shared the exercise questions of the chapters for which I asked you. So in the same manner, for this chapter also, for multiple factors and multiples, make a PDF or just take the pictures of the exercise questions and share it after today's class. Okay, now?
Of this chapter, I should make a PDF.
Yeah, if you know how to make a PDF, or if you have just a picture, you can take the pictures of the exercise questions of this chapter, then make sure that you share it. Okay.
Okay.
Okay, good. So let us start the chapter. Let us continue with the chapter. So far in the chapter, we have learned about factors and multiples, right? And both of them are related to each other. We learned that a factor of a
Sir?
number is, yes.
Nothing. Nothing.
Okay. We learned that a factor of a number is the number that divides it completely without leaving any remainder. Right now, getting it. So we learned about that also, right? And we know that to find factors or multiples of a given number, let us say you have a number, let us say you have a number p, and we have to find the list of numbers that will divide this number p without leaving any remainder, right? Now, so for example, let's say we have a number p, let's say you have a number 28, for example. So first of all, we would be writing down the numbers that would be, we would write down two numbers whose product would give 28. As we learned, like the product of 4 and 7 is going to be giving you 28. So 4 and 7 are the factors of the given number, right? Or 2 times 14, that also gives you 28. So 2 and 14 are the factors of the given number 28. Or similarly, 1 times 28, that is also the factor of the number 28. Like this, we learned this right now. Okay. Also, in another way, we learned that 28 is a multiple of 4 and 28 is a multiple of 7 also. So this thing we learned so far, and we did learn about prime numbers, we did learn about composite numbers, we did learn about twin prime numbers right now. Okay, so let us revise those topics quickly, then we are going to continue with the lowest common multiple. Today we're going to be learning about lowest common multiple and what are the different ways using which you can find out lowest common multiple of a given number. So first of all, tell me, what do you understand by composite numbers?
It's least common multiples, not lowest.
Mm-hmm.
Is least common multiple.
Yeah, least common multiple. I'm asking you about the composite number. Composite number. Tell me about composite number. What do you mean by composite numbers, Habib?
Can I see and tell?
Okay, no worries.
Composite numbers is a number which has more than two factors Example 4, 6, 8, 9, 10, 12, 2, 5, 16,
Good.
etc.
Good. Next, define prime numbers and give some examples also.
Twin primes.
Prime numbers, just prime numbers. Then you are after prime number, you will define twin primes.
There is no definition of prime numbers.
How can it be that there is no definition of prime number?
I did number having exactly two different. A number having exactly two different factors are called prime numbers.
Okay. Namely, they are see for
One and itself.
the one and the number itself. Good.
Yeah.
Okay. Then we did also learn about twin primes, right? So explain what do you understand by twin primes.
A
Also
twin
give some
prime.
examples of twin primes.
A twin prime is a pair of prime number that refer by two.
Good. Can you give some examples of pairs of twin prime?
Example. 2, 3, 5.
2, 3,
5.
5.
Yes.
The pairs of the twin primes are as follows. Like you have like 29 or 31. These are prime numbers and they differ by 2. Or you have pairs like 3 and 5. They are twin primes. If you can recall, we did learn about this one in the class. Or like 11 and 13. Both of them are prime numbers, right? But they are called as twin primes, as you can see in this slide, right? So the numbers, all of them are prime numbers, but the important thing is that, as you said, they differ by 2. Okay. So the pairs examples of twin primes are as follows. You have 3 and 5, 5 and 7, 11 and 3. All of them are examples of twin primes. Is that clear?
Yes.
Okay. And in between the twin prime numbers, in between the pair of a twin prime, there will exist a composite number. Like between 3 and 5, you have a composite number 4, which has got more than 2 factors. Similarly, between 17 and 19, what is the composite number?
19.
No, that isn't correct. I'm asking you, what is the composite number found between 17 and 19? Which number is there? Obviously, it's
17.
listen carefully to the question. First of all, listen to the question completely properly. My question is that, as the important point, as you would have noted this down, between twin primes, only one composite number is found. Between between twin primes, one composite number will be found. And as per the definition, composite numbers are the numbers which have got more than 2 factors. Okay. So between 17 and 19, the number 18 exists, right? And 18 is a composite number, isn't it? Yes, Habib?
Yes.
Okay. What is the composite number between 29 and 31?
And 30.
30, obviously. And 30 is a composite number, isn't it? Between
Yes.
11 and 13, you have
12.
12. So that is also a composite number. So between every two prime numbers, between twin primes, there will exist a composite number. So hope that was also clear to you. Okay, then we did learn about multiples and we learned about how multiples of a numbers are found. Okay, can you tell me about the important properties of multiples of a number which we studied? Tell me, what are the properties of multiples of a number?
The multiples of a number are unlimited. The multiples of a number are equal or greater than it, except
And
for 0.
okay, and
Multiple of 0 is 0 itself.
And 0 will be a multiple of every number, right? Now 0 will be
Yes.
multiple of every number. Okay. Also, every number is a multiple of itself, right? Like 3 ones are 3, 193 ones are 193. So every number is a multiple of itself. Also, also we learned that every number is a multiple of 1. Every number, isn't it a multiple of 1? Yes, Abhi.
Yes.
So every number will be a multiple of 1. So this is something which we learned. Okay. We did learn about common factor also. Was this concept clear to you? Common factors. Then we learned about common multiples as well. Today we are going to learn about lowest common multiples. In fact, I did give told you about the lowest common multiple in the previous class also, but today we are going to learn about the various methods using which we can find the lowest common multiple. First of all, read the given paragraph. Yes, Habib, read the given paragraph. I guess I'm audible to you.
The least common multiple is also known as LCM or the lowest common multiple in math. The least common multiple of two or more numbers is the smallest number among all common multiples of the given numbers.
Okay. So it is the basically the smallest number among all the common multiples of a given number. Like for example, here multiples of 2 are written as follows: 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 as follows. Then multiples of 10, multiples of 5 are also written over here, right now. And by the way, this is the number line on which we write down the numbers. This is called as number line. Okay. This over here is the number line on which numbers are being shown. So the common multiples of 2 and 5 over here is 10 and 20. This is the first common multiples. Getting it now? Out of the two, 10 is the least common multiple. It is smaller in value. So thereby the LCM of 2 and 5 is 10. As simple as that. Then the question is, how do you find using the multiple method right now you have find out. We listed down the multiples of 2 and 5 first of all, right, Habib? We have listed the multiples of 2 as follows. Then you listed the multiples of 5 as follows: 5, 10, 15, 20. Then you observed which one of them is smaller, so that becomes the LCM. So like this, there are different methods of finding the LCM. It can be calculated using various methods. Usually we use three methods to find the lowest common multiple. The first method, just now with the help of example, as you have seen, by listing the multiples of the given number, you can find its LCM. You can find the lowest common multiple. As for example, like you have written the multiples of 4 and 5 as follows. So you can see what are the common multiples. First of all, answer to me. What are the common multiples of 4 and 5?
Uh, Common multiples of 4 and 5.
Common multiples of 4 and 5. What are they? As you can see in
20,
this image,
20
20
and
and 40. Good. So it is
but
20
20 is
and
LCM.
exactly. So 20 is the LCM. It's the lowest common multiple. Very good. So that is the first method by listing the method. It is called as listing method where you list out all the multiples. Got this now? Where you list out all the multiples. So hope that is clear. Furthermore, we have got another method of finding out the multiples. That is the lowest common multiple. Okay, now that is the lowest common multiple. So that is the prime factorization method. So in prime factorization method, what we are going to do, first of all, let us learn about what is prime factorization. So prime factorization, read the given paragraph.
Prime factorization is the process of writing a number as the product of prime numbers. Prime numbers are the numbers that have only two factors, one and the number itself. For example, 2, 3, 5 7, 11, 13, 17, 19, and so on are prime numbers. Prime factorization of a number means to represent that number as a product of prime numbers. For example, the prime factorization of 40 can be done in the following way.
Like for example, we have a number 40. So basically, prime factorization method says that here you would be writing the given number 40 as the product of prime numbers. Like we could have written 40 as 10 times 4, but are 10 and 4 prime numbers? Obviously, no, they are not prime numbers. So we have to show it in such a manner that it is shown as the product of prime numbers. You understood what we're trying to do? Okay. So prime factorization method can be done in the following way. Let us understand. So 40 can be written as 4 times 10s, as we saw moments ago. 4 can be further broken into 2 times 2, isn't it? Yes, Abhi.
Yes.
And 10 can be written as 2 times 5. Okay. Now we are getting the numbers 2, 2, 2, and 5. Aren't these the prime numbers? These are prime numbers now. Getting it? These are the prime numbers, isn't it? You understood
Yes,
what
sir.
I'm saying? So the prime factorization of 40 is as follows. That is 2 times 2 times 2 times 5, like this. That is the prime factorization of the given number 40. So hope that is clear to you. Okay now. So how are we going to use this prime factorization method in order to find the LCM? Right now we haven't found the LCM. This is just the prime factorization of the given number. You have shown it as the product of prime numbers 2 and 5. 2 is being multiplied 3 times and 5 is just there as one time. Okay, no? Okay. By the way, I just received the PDF of the chapter you have shared. There's one problem in it. There's just one problem in it, Habib. Make sure that whenever you make a PDF of the chapter, now, then click the photos
Sir,
in the
every
portrait
chapter.
mode. No, whenever I would be asking you for the exercise questions of a given chapter, for that chapter only. Okay, now usually we'd be doing all the chapters now. So for every chapter, you'd be required to send. See, it would be better if you were to send the pictures in the portrait mode instead of sending it in the landscape mode. You understand the portrait and landscape mode?
No.
See, portrait is like this in this mode. Landscape is in this mode. Understood? You know what I'm saying?
Yes.
That is portrait. Because if you were to send it in the landscape mode, now I would be having it would be difficult to look at it. Okay, now I would be having problem in looking at it. Getting it? Like I would have to tilt the screen, or like in the PDF, it would be difficult to rotate the image in the PDF. Okay, now. So if it would be possible for you, can you please resend those, resend that PDF while by taking the picture in the portrait mode? Yes, Abhi.
Okay.
Okay, if it's possible, reshare it. Okay.
Just now my mother sent you the PDF.
Yeah, I did saw the PDF. That's why I told you. After looking at the PDF, I did told you that some pages in it are in the landscape mode. It would have been convenient if it were in the portrait mode. Okay, na? In this mode instead of this mode. Okay. So we learned about prime factorization method right now. Is that clear to you? I'm going to give you one question. Write write down the prime factorization of 18.
What?
Right, do the prime factorization of the given number, just like we did the prime factorization of number 14, and this is the answer over here. Like this, do the same thing for 18. Do the prime factorization of the number 18.
Two nines are
Okay, then
and 1
Yeah.
twos are.
No need to do 1 2s are. Okay, no? Because we already have got a prime number here. But 9 is not a prime number, so it needs to be broken down further. Hmm.
3.
3 times 3, no?
Yeah, 3 times 3.
3 times 3. So the 18 is 2 times 3 times 3. Getting it now? That is
Yes.
the prime factorization of 18. Okay, solve one more question. Find out the prime factorization of the number 26. Then also find out the prime factorization of 78.
Two 13s are 26.
Very good. 2 times 13. So 2 times 13, that is its prime factorization. What about 78?
So I don't know how to do that.
Okay. That is easy now. See, read the table of 13. Yes. Have you memorized it or not yet? Read the table of 13 quickly.
13 ones are 13, 13 twos are 26, 13 threes are 39, 13 fours are 13 fours are
52.
52, 13 fives are 65,
Hmm.
13 six are 78,
Hmm.
then 13 eights are 8,
Stop them. 13 6 are 78. Okay.
78.
So we can write it as the product of 13 and 6. Okay. 13 is a prime number. No need to do anything to this number. 6 is not a prime number. So you have to break it in the product of two prime numbers, 2 and 3. Right. So all these numbers are prime numbers now. So 78, its prime factorization is 2 times 3 times 13. Got this now? Yes.
Yes.
So this method that we just right now have learned how prime factorization is done. This method is called as factor tree method. This is called as factor tree method. Getting it now? Okay. Does it not look like the branch of a tree like 850? Its factors are 25 and 34. Further, the factors of 25 are 5. 34 is broken down in the form of 17 multiplied 2. Right now, getting this over here. So here, this is the final answer to this question. So do tell me that does this shape not look like that of a tree? That is called as factor tree method. Getting it? Like this. Understanding it now? So this method of finding of doing prime factorization, that is called as factor tree method. Okay. This 5 square is written over here because 5 is 2 times. So in short, it is written like this. This is basically 5 times 5. So the prime factorization of 850 is 2 multiplied 5 multiplied 5 multiplied 17. That is the answer. Is that clear to you for this one?
Yes.
Okay. Let us, using the same factor tree method, find the factor of 240. Will you be able to do this? Of course, you would be able to do this. Give it a
Yeah.
try. Okay.
So first, can we break it into
Hmm.
24?
24. Yeah, you can write that down as however you like. Okay, no? However you wish, you
12,
can do it. Hmm.
12 twos are 24. Then we just have to add 0, right?
12 twos are 24. Yeah, so here you have to write down 20.
Yeah,
Right now. 12
12
twos are
24.
24 and write 0 over here. Good.
Then after that, 6 twos are 12.
6 twos are 12. Good.
And 2 tens are 20.
2 tens are 20. Very good.
Or 5 fours are 20.
5 fours are 20. 2 tens are 20. And here you have to break down 10 also, no? So it would be 2 times 5.
5. Yeah.
Getting it. 2 times 5.
Then
Okay. Then what about this 6?
uh, 3, 3 twos are 6.
3 twos are 6. Very good. So that would be 3 twos are 6. So now at the end we have got prime numbers, right now? Getting it.
3, 2, 3
Mm-hmm.
multiplied by 2 multiplied by 2 multiplied by 5.
No, not. It is not completed yet. The product should be equal to 240. Okay, now. So the numbers that you are getting over here are as follows: this 3, this 2. 3 twos are 6. 6 twos are 12. 12 twos are 24. 24. 24. Twos are 48. 45. 48 fives are 240. The number that you are having at the end, this number, whichever prime numbers you are seeing in this tree, all of them would be counted. Okay, now all of them would be counted here. Getting it now? Like the composite number 6 or 10 that hasn't been taken, 20 and 12 that is not counted here. All the prime numbers that you see in this tree, okay, now will be taken into the prime factorization of the number. You understood what I'm saying?
Yes.
3, 2, this 2, this 2, this 2, and this 2. So how many twos are there?
4 twos.
4 twos. So that is the prime factorization of 240. Okay. So right now you have just only learned about the prime factorization. We are yet to learn about the about how LCM has to be found. Okay. Okay. Say for example we have two numbers. Say for example we want to question says that find LCM of 60 and 90 using prime factorization. That is the question. So first of all, you will do the prime factorization of the given numbers 60 and 90. So do tell me how can we write them down? So can 60 be written in this manner?
2 30s are 60.
2 30s are 60. Very good. 30 can be further broken into 2 times 15, isn't it?
Yeah.
15 can be further written as, yes,
2, 3 fives are 15.
3 fives are 15. So what are the prime numbers we have here? 2, 2,
2, 2,
3,
3, 5.
right? Okay. So the prime factorization of this given number 60 here is that prime factorization, PF, in short, prime factorization. 2 times 2 times 3 times 5. Okay. Now talking about the another number, you have to answer this one. I'm not going to answer this one. For 90, you find it out. Take your time and find out the prime factorization of 90. Yes, Abhi. Done?
Yeah, almost.
Okay.
Yeah, done.
Done? Okay. What's the answer?
3 multiplied by 3 multiplied by 2.
That's it. You missed 5.
Yeah, 5.
Okay. The prime factorization, of this number over here is 90 equals to 2 times 3 times 3 times 5, right? Okay. 2 3s are
Yes.
16, 6 3s are 18, 18 5s are 90. You can cross check it in that manner also. If the product gives you 90, then it is correct. Okay. Now let us understand the real thing. We have find out the common factors. I mean to say, we have find out the um, prime factorization of the given numbers. Let us understand how we are going to find the LCM. Okay, now. So what you are going to do, observe the number of times 2 is written here. 2 is written 2 times. 2 is written only 1 times here. Okay. Observe the number of times 3 has been written here. 3 has been written here just 1 time, and here it is being written as for 2 times. Okay. And 5 in both the places have been written just once. Okay. Now the method says that here you have, as we have written the prime factors of the given numbers. Okay, it has been written over here. Now in order to find the LCM, what you are going to do, you are going to take only those prime factors that have the maximum number, that are more in number. Like for example, you are going to take 2 over here. 2 out of this and this. In which case it is maximum. In the case of 60, it is 2 times now. So you will take these 2's. Got this so far? So far you got this or not?
Yes.
Okay. Then about 3. Either we are with should we take just this 3, or should we take this 2 threes?
These 2 things.
These 2 threes as per the rule. We are going to take these 3. Take these 2 threes, and as per the number which is present the same number of times, then you are going to simply write that down. Okay now. But if there were to be 2 5s, for example, over here, if there were to be 2 5s in such for example, if there were to be 2 5s, then how many 5s you would have written here?
2.
You would have written 2 5s. Okay now. So hope so far you have understood this. Now simple thing is that just find out the product of these numbers. Find out the product and do let me know what answer you are getting quickly.
Means I need to multiply.
Exactly. Product basically refers to multiplication here.
$45.
How can it be 45? I think you need to do some practice on
Yes,
multiplication.
I'm doing.
Hmm. See, at the end of the class, I will give you 5 questions as a practice question. Okay. After the class, make sure that you solve it and ask your mom to send the solution on my WhatsApp number. Okay. Going to send you some questions on multiplication at the end of the class. Okay.
One 80.
180. Very good. So that is the LCM of the two numbers 60 and 90. Hope that is clear to you. Okay. Also, this is the second method using second method to find the LCM. The first method was by listing the multiples of the given number like this one. If we
Sir,
were to, yes,
can I drink water and come?
yeah, sure.
Yes, I can.
All right. So we could have found out the LCM of the numbers 60 and 90 by listing out their multiples also. Right now, like, let us verify that. For example, you have 60 over here and 90. Using the first method by listing out the multiples, find out what would be their lowest common multiple. Start by writing the multiples of 60 and 90.
Sir, how? I don't understand.
We have to, like moments ago, you learned about how you can find the lowest common multiple, that is LCM, by the prime factorization method. Did you understood that completely?
Yes.
Good. Also, we know that the LCM of the same number can be found out using the using the first method also. Like, we had found out the LCM of the number 4 and 5 by listing out their multiples, and then you found out that 20 is their common multiple, lowest common multiple.
Oh,
Same
understand.
method can be done here also. Okay, now
Understand.
understood. Okay, find it out using the same method. First write down their multiples. Yes, so we've done by now. You should be done.
Yeah, just 2 minutes. Just 2.
Okay.
Sir, I found
Hmm. What is the answer?
509. I mean 180 LCM.
180. Very good. Right now, so it would be same basically. 61s are 60, 62s are 180, 63s are 180, 60s, 4s are 240. Like this, we can continue up to infinity. 91s are 90, 180, 270 like this. So now we have found out here that 180 is the lowest common multiple right now. So out of the two, which one is more easier? By the first method, by listing out their multiples and then finding out the common multiple. This one is easier, but we have learned about prime factorization method also. So if examiner asks you to solve the question using that method, using prime factorization method, so you can find it out using that method also. So I'm going to give you some questions using the prime factorization method. You are required to find the LCM. Okay, now. So do one thing, find the least common multiple of the given number. Take the number 30 and take the number 40. Find out the least common multiple using prime factorization method. That is the question.
How?
Just now, moments ago, we have learned this now. The same thing.
Oh, okay. ठीक है.
Okay, now.
Sir,
Yes, done.
I did the factorization and I got 3x10 x 2x5.
You are getting 10 also. Is 10 a prime number? You have to break it down further into prime numbers in the as the into product of prime numbers. Huh? What
The
is your
answer
answer? Mhm.
3x2x5.
Okay. So the answer is what? These are the prime factors, okay? But which is the what is the LCM?
I don't know how to found that. I forgot.
Okay, see basically 30, how did you broke down 30?
By 3 by 10.
By 3 and 10,
Into
okay?
10.
3 into 10. 10 will be further broken in terms of 2 times 5, okay? So you have the prime number 2, 2, 2, 5 and 3 here, okay? Then you have to stop there. 40 can be written as 4 times 10. 4 can be written as 2 times 2, okay? 10 can be written as 2 times 5. All right. Now write down the factorization of 30 first of all. That is 3 times 2 times 5, okay? Then write down the prime factorization of 40 also. That is 2 times 2 times 2 times 5. Clear so
Sir,
far?
we can also do 22, right?
Of course, we can do that also. But the end value, you'll be getting the same value. Like, for example, let us do as you say 40, you're saying 2 times 20. 20 will be further written as 4 times 5. 5 will be further written as 2 times 2, right? So, what are the prime numbers you are getting? You are getting this 2, 2, 2, and 5. Same as you were getting here 2, 2, 2, and 5. Got this now? Yes, Habib?
Yes.
So what no matter what numbers you'll be taking initially, but at the end you'd be getting the same prime numbers. You will end up with the same prime number. Okay, now as per the rule, what I said that find out the numbers which are repeated for the maximum time. Like 3 here is being repeated is being in is found on the in this number only. Okay, it is not found in the second number, but we are going to take this. Okay, now we are going to count this. Then 2 out of 30 and 40, in which one 2 is being repeated maximum time? Of course, in the case of 40, isn't it? How many times? It is 3 times. So just write it as it is. Here it is only one time. Here at it is being repeated for 3 times. So wherever the prime number is written for maximum time, it is being repeated maximum time. For that one you have to choose. So far, is it clear?
Yes.
Okay. And 5 here is being repeated the same number of times. So just write it as it is. Okay. And here 3 was written, 3 is the prime factor of 30 only, but not of 40. So we don't have to leave it. That will also be counted in it. Okay. Now, got this
So
now.
this is
That will
called
also,
LCM.
this is,
Called LCM.
yeah, this, the final product will
This
be called
answer.
as LCM. Hmm. The answer to this will be called as LCM once you multiply all this. So quickly multiply this.
120.
120. Very good. Right now. So that is the answer. The answer in this question over here is that it is 120. So hope you have understood this properly. How about you solve one more question? Okay, solve
Okay.
one more question. Okay, now. So we
Okay.
have few minutes remaining. So pick any two numbers. I'm giving you the choice.
You pick.
Okay. So how about I give you the number 45, and then you can take another number as, how about you take the number 38? Find find out the number LCM of 45 and 38. Okay.
So what is that? 30. Oh, that's another question.
38.
No, no, no.
Yes, Habib.
So I'm almost done.
Okay, okay. Yes, Habib. Done or not?
So I got a big answer.
Yeah. What is the answer?
10,260.
10,260. This all you're getting. Okay, let's check it out whether it is correct or not. So it would be 5 times 9. 9 would be broken as 3 times 3. Okay, now 38 will be written as 2 times 19. No need to break it down further because 2 and 19, both of them are prime numbers, right?
Yeah.
Okay, so the prime factorization of 45 is 5 times 3 times 3, and that of 38 is just 2 times 19. So here we are finding out the LCM in this manner. Right now, all the numbers should be here multiplied. Right now, 5 is here, but it is not here. So simply write down 5. 3 is here written for 2 times. It is written not for even a 1 time here, not for even a 1 time. But simply you have to write down this. Okay, no, 3 times 3. 2 will be also written, 9 will also be written. Okay. So let's check it out. What answer you're getting? 3 threes are 9, 9 fives are 45, 45 twos are 90. So 90 multiplied 90. 99s are how much? Multiply 19 with 9. Read the table of 19. Have you memorized the table of 19 or not?
No.
Not yet. When are you going to revise the table? Yes, Abhi. Yeah. Right after the class, the first task that you would be doing is you would be learning the tables up to 20, up to 19. Okay. 99s are 171, and you simply put the 0. So the answer to this will be 1710, not 10,260. Is that clear?
Yes.
And kindly check where you have done the mistake. If possible, send a picture of it to me. I will have a look at it where you are doing the mistake. Okay. And as I said, at the end of the class, I would be giving you some questions to solve in multiplication. So if possible, take the screenshot. You have to find out 38 times 2 times 17 equals to how much? Find out 19 times 3 times 53 is how much? Then 18 times 5 times 6 times 7 is how much? Then
This is homework.
188. Yeah, that is not the homework. It is not part of the homework. Okay, no? Because assignment will be given to you from factors and multiples, but this is just some extra question you have to solve, because I saw that your multiplication is not that good. You need to practice some questions. Can you take the screenshot?
I might.
Okay. Yes, Habib, done.